So question 1 asks you to select which of the following are surds. So we know that surds are numbers which are left in a square root form or even a cube root form. They are therefore irrational numbers. The reason we leave them as surds is because the decimals would go on forever. So therefore we need to work out which ones are surds and which ones go on forever. Root 17 is an example of a surd. Root 36 can be simplified. You know that root 36 is equal to 6. Just like root 100, you know the square root of 100 is 10. Root 15 cannot be simplified, so is irrational and is a surd. And finally, root 30 cannot be simplified and is irrational and therefore a surd. So, in the video you will have seen that there are two surd rules you need to remember. The first one is the multiplication rule. This tells you that root A times root B is exactly the same as root AB. So for example here, root 11 times root 11 is the same as root 11 times 11, which is equal to root 121. Can you simplify it? Yes, you can. A lot of you might have already spotted a bit of a trick, and this is an additional rule you can remember, and that is root A times root A is always equal to A. So here root 11 times root 11 is equal to 11. We're going to use that and apply that rule for question B. So root 5 times root 5 is 5. Root 10 times 2 times by root 2 is equal to 2. 5 times 2 is equal to 10. We're again going to use this rule. Root 6 times root 6 we know is equal to 6 times by this third root 6, which is then just equal to 6 root 6. Just like in algebra, we don't have to write the times sign, so we can just place them together and that automatically means that they are being times. Simplify fully these surds. So just like before, we're going to be using this rule, root A times root B is equal to root AB. However, this time we're using it backwards. So first of all, what you need to do is spot a square number which is a factor of 12. We know that 4 times by 3 is the same as 12. We can then use our rule backwards and separate our surds into root 4 times root 3. Root 4 we can evaluate is 2 times root 3, which is the same as 2 root 3. We can do exactly the same procedure for the next part. So root 27 is the same as root 9 times by root 3. And again, we can simplify root 9, which is 3 times by this root 3. Our final question, slightly harder to spot what square number goes into it, so for questions like this you might find it useful to write down the first few square numbers, and then you might find it easier to spot that 25 goes into 50 twice. We again use our rule, working backwards, and we simplify our root 25 to 5 root 2. This question, question 4, you will need to use the fact that root A over B is exactly the same as root A divided by root B. So we can actually separate our two surds into root 25 over root 16. We can evaluate the top, root 25 is 5. We can evaluate the bottom, root 16 is 4. Then we've finished. We can do the exact same thing for part B, but again working backwards. So here we can simplify it to 18 over 8, and then we can simplify our fraction. 18 over 8 is the same as 9 over 4. And now we're going to again work backwards, and we're going to separate our surds to root 9 over root 4, which is equal to 3 over 2. Simplify the following surd expressions. So, like you've seen previously in algebra, if I asked you what 5a minus 2a was, you would tell me there are 3 lots of a left, so 3a. It's exactly the same here, apart from our a has been replaced by root 5. So 5 root 5, take away 2 root 5 is 3 root 5. Same works for addition. 8 root 7 plus 3 root 7 is 11 root 7. Question 6. Simplify the following surds. Again, this goes back to being able to spot a factor, which is a square number. So here, factors of 8, which are square numbers. Again, I'll write them at the top, as this might help you spot which one goes in each. So here, root 4 times 2. Split up your surds and simplify. Next one, root 4 times 3. Split up your surds and simplify. Finally, the last question, you can take out a factor of 16 times 2, split up your surds and simplify. Again, using our division rule, where we can rewrite them as 2 separate surds and evaluate them separately, which will give you the answer 3 over 5. Part B is a bit trickier. We're actually going to use what we're doing in question 6, so we are going to simplify root 12 before we do anything. So we've got root 12 is equal to 4 times 3, which we can separate and evaluate separately. So root 12 divided by root 3 is actually the same as just 2 root 3 divided by root 3. Now here you will spot that root 3 is on top and bottom, so we can cancel both of those out to get our final answer of 2. Part C, our final question. Again, you will notice that actually we cannot simplify root 15 by picking out a square number factor. However, we could rewrite 15 as root 5 times root 3. We can then split up our surd into root 5 times root 3, and that is all over this root 3. And you will notice again that we can cancel out root 3 on top and bottom, leaving us with our final answer of root 5. Again, links into that previous question where we've got 6 lots of root 2, take away 5 lots of root 2, leaves you with 1 lot of root 2, or just root 2. Remember, just like in algebra, if I were to write the letter A, that is also the same as 1A. This next one, again, we can use that rule which we've just written down. If this helps, we can put that imaginary number 1 in front, and then that tells us we will have 4 lots of root 11. So again, we're looking at simplifying these surds. I'm going to straight away put in that imaginary number 1, and then we just work from left to right, because we use the BIDMAS to help us remember what order and addition and subtraction are completed at the same time, so we just work from left to right. 7 take away 2 is 5, plus 1 is 6, take away 3 is 3, lots of root 3. 5 plus 4 is 9, minus 8 is 1 lot of root 7, or just root 7. Both answers are perfectly acceptable in the exam. Simplify the following. So here we've got 2 separate like terms. So when we previously have looked at questions like this, where you've got A's and B's, you would collect together your A's to get 5A, and you would leave your B's. We're going to do a very similar process here. So 9 root 3 minus 4 root 3 is 5 root 3, and then we have 1 root 5 plus 2 root 5, which gives you a total of 3 root 5. I'm going to do a very similar process here. We'll identify our like terms. 10 root 2, take away 6 root 2 is 4 root 2, and then we have our last term plus 4 root 7 on the end. So they've started using some algebra. All we've got to remember is AC means A times by C divided by B. So we have root 2 times root 10 all divided by root 5. We can first of all use our multiplication surd law, which tells us that we can group our surds together. Root 2 times root 10 is root 20 divided by root 5. We're now using our division law, which tells us that we can write all of this under one surd. That allows us to evaluate the answer. 20 divided by 5 is the same as root 4, and root 4 is equal to 2. We've given our answer in its simplest form. Work out the mean of these numbers. So this is linking in our work from statistics. To work out the mean, we need to add those three numbers together and then divide by 3. It wants it in the form a root 3, where a is an integer. You don't need to worry about that for the time being. That is just giving you a hint as to what your answer should look like. So what it wants us to do is add these three surds together and then divide them by 3 to work out the mean. So at the moment we cannot add these together. However, if we simplify each surd, we should be able to collect our like terms. So root 27 is exactly the same as root 9 times 3, which is root 9 times root 3, which is 3 root 3. Root 48, that is equal to root 16 times 3, which we can again separate to 16 times root 3, which is equal to 4 root 3 after we square root 16. And finally, root 75 is equal to 25 times 3, which again we can separate to root 25 times by root 3. We can evaluate the root 25 to get 5 root 3. Now we need to add these together. This is exactly the same as the simplifying we saw earlier. So 5 plus 4 plus 3 is 12 root 3. That is all divided by 3. 12 divided by 3. We can cancel this fraction down just like you usually would. So 3 goes into 12 4 times. So therefore we are left with our final answer of 4 root 3. If you struggle with simplifying fractions like that, just picture it as 12a divided by 3, and then hopefully you would spot that 3 goes into 12 4 times and you get the same answer. So it wants root 99 plus root 44 in this form, a, b, where a, b are integers. Remember, integers just means whole numbers. So we've got to transform both of these into that form, which means our surd part for both of them would have to be the same. So let's start with root 99. I know I can write this as 9 times 11. I've picked out a square number, which is a factor. I can separate my surds, and I can simplify by square rooting my root 9. If I do a similar process, and remember that I'm trying to end up with something root 11, that might give me a bit of a hint as to what I need to do. So root 44 can be simplified to root 4 times 11, which is the same as root 4 times root 11, which again we can simplify. Root 4 is the same as 2 root 11. And finally we need to combine and add these. So 3 root 11 plus 2 root 11 is equal to 5 root